and welcome to Microbiology at Junior College. Today what we're going to do is we're going to go over microscopy, and specifically we're going to learn how to use the oil immersion lens today. To illustrate the use of the oil immersion lens, we're going to use Carolina's bacterial type slides, and I'll show you guys images of the different types of bacteria that we will be able to view under the oil immersion lens. So my first statement I'd like to say is, why do we use an oil immersion lens in microscopy? And it really boils down to, one, oil immersion lenses afford us the ability to have high resolution while having a high magnification. Most of the lenses we've worked with in the past, especially if you've taken anatomy or mammalian anatomy, are designed so that they can actually work through air as a medium. So we've used in the past the scanning power, low power, and high power as a means of viewing like histology slides or other types of slides in our previous courses. These lenses are specifically designed to work with air as a medium. However, in microbiology, we're primarily going to use the oil immersion lens to magnify our samples. The oil immersion lens is going to be 100 times magnification. So if we look at the total magnification, which includes the objective oil immersion lens and the ocular lens, there'll be a total of 1,000 times magnification. So that will make it easier for us to see the bacteria, which are so tiny and small. I did want to talk a little bit about the lenses involved in the oil immersion lens, and how does the use of oil contribute to this magnification and better resolution. So on the board, I'm going to kind of show some images, or try my best to illustrate the images when it comes to the components of the microscope. So at the base, when we're looking at the microscope, we're going to have the light source. So that's going to have a light bulb. It's going to help us see the particular structures. Let me see if it's showing up on camera. A little bit, not perfect, but it's there. So what's going to happen is light is going to shine up from this light source. And the first type of lens that it's going to encounter is actually below the stage. This is called the condenser. And the condenser is a double lens. And the job of the condenser is to take these beams of light and focus them onto the sample itself. So here we can see a lot of light coming up, and eventually what will happen is that light will actually be focused to a point onto the sample. In between the light source and the condenser, we have this tool called a diaphragm, or the iris diaphragm. This is kind of an aperture that is available to be able to control the amount of light hitting the sample. As we increase magnification, the amount of light actually going through the lenses decreases, because as we'll see later on, the beams of light will actually refract. And as we get closer and closer to the sample, we at higher and higher magnifications, less light is actually going to enter the lens or enter the pipe that composes the objective lens. Because of this, as we increase magnification, we have to open the iris diaphragm more and more and more to be able to see the sample effectively and have a good amount of contrast between the background and the sample itself. Past the condenser, we're going to actually have the stage. This is a mechanical stage. And the stage is where we're actually going to rest our sample. This is where our slide will be. I'm going to kind of adjust the light a little bit so it actually goes through our sample. So you can see that the condenser is actually treating the sample and hitting the slide at a particular point. So all of that light is shining where we need it to go. Above the slide, we're actually going to have our objective lens. And so here I'm just drawing the pipe that it's located in. And we're going to have a few lenses in here. And so that's going to be the scanning power, low, high, and oil immersion. And so the options that we can have is scanning will be 4x, low will be 10, high will be 40, and oil immersion will be 100 magnification. There's another lens above this, and then eventually the ocular lens. So what happens as light is shining through the slide? Let's say we're looking at either the scanning low and high power lenses that uses air as a separation or a medium for the light to travel through between the sample and the objective lens. One of the things that happens is because there is a we're changing the type of medium from glass to air, the light will actually refract and scatter. So some of the light will go into the lens, or the objective lens, but others will be kind of moving away from it. Or it will even bounce backwards through the slide. So it'll hit the glass, the edge of the glass, and come back. So this is one of the things that, the issues that we're really dealing with, is all of the light that is shining through our sample is not actually entering our objective lenses. And as we increase magnification, this becomes more and more of a problem, and it reduces the resolution and the brightness that we see. When light goes through the objective lens, what will happen is it will actually bend, and this will increase the magnification. And this middle lens will actually bring the light into the ocular lens, so that we'll actually be able to see the sample. This objective lens is going to be convex, meaning it's going to go out. And so that's what helps aid in the magnification process, is the shape of the lens. So, yeah. So normally what will happen is, with this at 4, 10, and 40x, it's okay for there to be this difference between slide glass and air, because the working distance is far away enough that it will catch a bit of the light, and so we'll still be able to see our sample. However, if we get to 100x, the working distance is so small that so much of the light kind of passes away from the lens itself. So we're not collecting enough light, and that's going to affect our resolution. So how do we deal with that? We're going to deal with that using the oil. So when we're working with oil, what we're going to do is we're actually going to put a little drop onto the slide, and this oil droplet is going to connect the slide and the lens. And this oil is specially designed to be able to work with the microscopy and work with this lens. And the important thing is that the refractive index of the oil is going to match that of the slide. So it's not really changing the type of medium it's traveling. And so the light is going to be directed straight into the lens rather than being backed away. So that's one of the reasons why we use oil. It prevents that refraction of light, and it funnels it into the lens. Maybe so? Yeah. Okay. So now what I'd like to do is kind of show you the process of using the oil immersion lens on the microscope itself. So I'm going to try to adjust the camera so that we can see this quite clearly. Just getting a slide. So we're working with the Carolina. It's not necessarily focusing. There we go. We're working with the Carolina bacterial types gram smear. And there are actually 3 different types of bacteria on this. I'll show you guys a image of that on the PowerPoint in a little bit. But you can always Google this this slide, and you'll be able to go directly to the Carolina's website and be able to view the different samples, different images that they provide online. So when we're working with oil immersion, the most important thing that I'd like you guys to be aware of is that only the oil immersion lens should ever come in contact with the oil. And the reason why is that it's sealed. The other lenses are not sealed. And so the oil can actually get into the pipe of the pipe. And then as a result, it can get directly onto the lens itself, and it will gum up the lenses. To fix it, we would have to actually send it to be cleaned, or like actually get it replaced completely. It would actually be cheaper to get a brand new one than have to get it cleaned. So be sure to be mindful every time you're working in lab that if you're using oil, use it only on the oil immersion lens. So how are we going to approach this oil immersion? So what we're going to do is when we're working with the oil immersion lens, I like to bring the stage downwards. So I'm going to direct it towards the microscope. We're going to move the stage down, and what we'll do is we'll actually take the high power and low power, high power and oil immersion lens and kind of straddle the sample or the slide so that we have a lot of working space here. So we can add a drop of oil without getting it onto the lenses quite yet. So I'm going to take this drop of oil, and you'll see that the oil, there's a little stick inside, and that stick will actually pick up a drop of oil for us. It's not like a dropper, like you might expect. It'll just be a glass rod. So when we are working with our oil, we're going to, what I like to do is I like to, with my naked eye, be able to find where the sample is, just kind of using the light to shine through it and be able to view that structure. And once I find the general location where it would be found, I take a drop of oil and I will actually place it on top of that area. Next, what I'll do is I will swivel the oil immersion lens over, and this is going to be the one with the white stripe for our samples. Then what I'm going to do, obviously this is backwards. Normally you would be facing the microscope, but I will bring the I'll bring the slide up, and I will kind of get to its level and make sure that the oil is actually connecting to the lens. You'll see it go from a dome shape to kind of like an hourglass shape when it connects the slide and the lens together. From there, I would actually view the I would actually view the sample and use the coarse focus, like a fraction of a bit, to move the image in place, and then the fine focus to make it nice. In a moment, after I'm working with the microscope, I'll actually show you the images that you should be able to see. And I'll give you a link so that you can actually go to the Carolinas website and to be able to see the images yourself. So before I move on though, I'm going to teach you guys how to clean the lens properly. So you would actually remove the slide, and then what you would do is you would, out of your kit, you would take your optical lens paper or optical lens wipes. This should be the only type of paper in the lab that should ever touch the lenses of the microscope. The reason why is that it's lint-free, and it also won't scratch the lenses. If the lenses get scratched, it will add to that refraction process that we talked about before, and the microscope and the lens won't work properly anymore. When you're done with this slide, when you're done with using the lens, what you're going to do is you're going to take this lens paper and you're going to just gently dab the lens with the lens paper, and you're going to move it to a different direction until there is no more drops of oil transferring to the paper. You don't want to rub this the lens, because again, you don't want to scratch it. So you're just going to gently dab it in a new location each time until the oil is gone. Yes, no, maybe so. The last thing I'd like to do is I'd like to show you what you should have been able to see under the microscope. And so let me open this up. Try to move it a bit closer. I'm not sure if the lighting will work. There we go. Yep, that's a bit better. So you should have been able to see three different shapes. One is going to be a bacillus shape. It's going to be a rod shape. And my question for you for here is, you can see that it's a bacillus, it's a rod shape, but they're located connecting end to end. What is the name of that arrangement? And I'm not going to give you the answer right now. You should be able to determine that for your assignment. The next type of shape is going to be a spirillum. The spirillum is going to have a spiral curlicue shape to it. And so that's its identifying feature. And then the last one is going to be like a coccus shape. Coccus is going to be spherical. So it's going to be round circles. And we see them clustered together like grapes. What is that arrangement called? So these are the three images that you should be able to see. And if you would like to know the names of these bacteria, the bacillus is actually going to be the Bacillus megatherium. So that's what the bacillus is called. The coccus is represented by the Micrococcus luteum, the same one that's yellow in our samples. And the spirillum is represented by the Rhodospirillum micro. Rhodospirillum micro. I hope that was helpful. Yeah. Let me turn on the light. I hope that was helpful and it addressed your questions and it kind of made up for the missed lab. If you have any questions or concerns, don't be shy to ask. All right, have a great day, okay? Bye-bye.